Alright, I'm going to try to go through some of the examples in, I believe this is lesson 12, and I'm looking at section 12.3 is where I'm pulling these problems from. So the first one I see is x squared plus 10x plus 9 equals 0. Alright, and we can see if I was modeling this, I have my x squared, and then I have 10 x's, which if I was just factoring like you guys are currently doing, right, I might go, I have 9 dots. How can I arrange 9 dots and get 10 bars? Well, this would get me 3 and 3. That would only give me 6 linear measurements. So that's not going to give me 10x. How else could I arrange 9 as a rectangle? Well, my only other option is a 1 by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would give me 1x, 2x, 3x, 4x, 5x, 6x, 7x, 8x, 9x. Alright, so this would be x plus 1 plus 9. Alright, so that's if we were going to factor form. Now, one thing that's uneasy about factored form is creating the, looking at those different ways to make a rectangle. I had a 1 by 9 and a 3 by 3. The other way of doing it would have been looking at all these different ways of rearranging the x values. So I could have tried, right, so if that's now 7, well, I still need 10x's. I could have then put 3 here and went, well, that's not 9 dots. So I could have moved around the linear terms and saw how many of the constant terms I had, right? So there is 2 different ways of factoring using area model or algebra tiles. All right, so with completing the square, I wouldn't even call it completing the square. I call it a difference of 2 squares, because there's 2 squares that are going to have come up in this diagram. One's going to kind of circumscribe and be a larger square, and there's going to be a missing square. So I still have my x squared. Now, the advantage of this compared to just regular factoring is my next step is already determined for me. I know I need to make a square, and I have 10 linear terms, so really my only choice would be 1 and 1, split it, 3, 4 and 4. All right, now I've used all 10. Now I can kind of look, with this being kind of circumscribed, I now have this big square that is x plus 5 by x plus 5, which means that there would be 25 dots here in this larger square. But I know from what I actually have, right, we have only 9 dots. All right, but again, I want to try to make a square. So really I want to keep a square in that corner, so I'm going to, didn't get the color. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and I'm always going to color it there. That way there is still the missing square up here. Alright, this is kind of my negative square. Now you might be wondering, well, is that always going to be a square, like a nice even numbers? And the answer is, if it's a factorable question, yes. If it's something that's going to give you whole numbers, yes. So for any of the completing the square problems, unless you're giving them something where it's going to be the square root of, right? If you have something where there's 13 dots left over and you have to add and subtract the square root of something, all of these kind of friendly completing the square problems, that will always happen. So what do we actually get out of this? Well, we have the larger square, which I've been using black, so I have x plus 5 squared. But then we have this teal amount, which is really a 4 by 4. So that would be take away 16, right? And this is really vertex form. Now, there's different algebraic ways of dealing with this afterwards, but the way I like to look at it, add another color, is I'm going to try to make it look like that up there. I'm going to try to make it look like one rectangle. So what I'm going to do is take this rectangle, and then I'm going to kind of, well, not that one, right here. Let me undo that. All right, so we got to remember that that teal space is actually just negative space. It's not actual amounts we have. So what I can do is take this amount here. If I turned it and flipped it, I'm actually going to get the same diagram as above. All right, so this is going to be 1, 2, 3, 4 that we're moving. And so what I really just did was I took, on this side, I took away 4, and on this side, I added 4. So really what we're looking at is this x plus, the algebra that would go with what I just did, which is really just going from standard form to vertex form to factored form, is this is x plus 5 squared, but we have a minus 4 squared, and then to get it in rectangular form, we have x plus 5 plus 4 and x plus 5 minus 4. Alright, so I get x plus 9 and x plus 1, and they already know how to solve that. Right, so you're getting that plus and minus 4 intuitively. I mean, I'm not having to say, well, there's 16 dots there, the square root of 16 is 4. Well, it's plus or minus 4 because 4 squared is 16, and negative 4 squared is also 16. I've actually added and subtracted 4 intuitively, really going from standard form to vertex form to factored form.